Okay, guys, so I posted this worksheet on Google Classroom and I'm going to make a couple of videos from it. This first video is I want to just give you some examples of a one-tail test because the previous video, the only types of tests I had on there, I did a two-tail test of each type. So the one-tail tests are very, very similar. We just have to follow some slight different formulas on our formula sheet and it changes our null and alternative. Well, just our alternative. So for this first one, Matt's bank issued an advertisement saying 90% of its customers were satisfied with the bank's services. So this is a claim about the population proportion. So they're claiming that the population proportion is 0.90. Since he himself wasn't very satisfied, he suspected the ad was false and that the percentage was actually lower. So this is what I meant in the other video when I said they will give you some sort of phrasing, some sort of clue as to how you're going to set this up. So he surveyed a random sample of 80, so that's our N, and found that only 80% were satisfied. So this is our P hat. Okay, so conduct a test of hypothesis. So another thing that I want to point out, at this point, I'm no longer going to break down the 5-step process for you. You can see I've just given you this big blank space. You still need to work through the whole 5-step process. And when I grade problems, I am looking for all of these different parts. So the first part, step 1 of the 5-step process, is your null and alternative hypothesis. So the null hypothesis is that the population proportion is equal to 90. Now we think it's not 90, and actually we think it's lower. So that means our alternative hypothesis is that P is less than 0.90. We have to, for step 2, give our alpha value. So unless they say otherwise, it's always 0.05. So I keep those. This is step 1. This is step 2. So step 3, we want to do our test statistic and critical value. So for that, I always draw a picture. Now, because we're doing just a left tail test, and I know it's left because it is less than, I'm going to have a critical value on this left-hand side. Okay, so this picture is part of step 3. So I'm going to go to my formula sheet and try to figure out how to find my critical value. So what I need to know now is which one of these am I using? Because this is dealing with percents, that makes it a one prop Z test. So that means I'm going to follow the general side of Z tests. So now what I'm looking for, I've got my left tail. So switch this. I'm going to do inverse norm. My area, I'm just doing my alpha value. I don't have to divide it by 2 since it's all in one tail. So I've got negative 1.645. So this is my Z critical. So now for my test statistic, here's my regular Z test, here's my one prop Z test. So I'm going to follow this formula for my test statistic. So I'm going to have my P hat, which is 0.80, minus P, which is 0.90, square root 0.90. Now, I always go ahead and do this subtraction. 1 minus 0.90 is 0.10, divided by my sample size, which is 80. So I'm going to go ahead and compute this. So just be careful typing it in. And I get negative 2.98. So just to reiterate, the critical value is how many standard deviations we can be away from the supposed mean without raising any red flags or suspicion. The test statistic is based on our sample, how many standard deviations were we actually away. So we we're clear over here at negative 2.98, which puts us in the reject region. Okay, so now step 4 is coming up with our p-value. So my p-value for a left tail, I'm going to do normal CDF, negative infinity to my z, which is negative 2 point, whoa, man, can't type today. And I do not have to multiply it by anything because it's a one-tail test. So I get a p-value of 0.001. So all of this falls in the reject region. This, I'm comparing my p-value to alpha. It is definitely less. So this tells me I get to reject the null. So then the last step is conducting a confidence interval. So I have to find the one prop z interval. Now, here's something we have to do too. We need to know what x is. Now, I've already done this, but what they have told us is that 80% of the customers were satisfied. So I have to figure out 80% of the 80 customers. So that means I have an x value of 64. So when I go to this one prop z interval, that's where I got this 64 out of my total, which is 80. So I now have an interval of 0.71 to 0.89. And this should support that same decision of rejecting the null. Is 90 in this interval? It's very, very close, but it's not in there. So we can't accept that that 90 might be the answer. So the last thing I'm going to do is interpret this. So my interpretation is we are 95% confident that the true percent, and I did choose to give it in percents this time since the original problem was in percents, is between 71 and 89%. Okay, so for the next example, it's thought that the average height of a kindergartner is 45 inches. You are a kindergarten teacher and you feel that your particular class this year is shorter than that on average. Using your data below, conduct a test of hypothesis to determine if the average height of kindergartners is actually less. So this is a test for means. So they're claiming that the average is 45. We think it's less. Now, test of means is either Z or T. So this one has to be a T test because we were not given a population standard deviation. Now, what we're going to have to do, because we were not given anything except a list of data, is we're going to have to go into L1 and type in this list of data. So I'm going to pause for a second and do that. Okay, so I have my data typed in. So what I'm going to do now is go to stat calc, and I'm going to run one variable stats, because then this is going to give me my sample information that I need. So X bar we found was 42.7, and the sample standard deviation that we have is 1 point, I'm just going to go ahead and call it 98. Sample size was 17. So we have to get those values that we're going to need for our different formulas to run this test. So now working through the 5-step process, null and alternative. So H sub O, they think that the mean is 45. H sub A, we think that it is actually less. So this is another left tail test. Alpha is 0.05. So now I'm going to do my critical value and my test statistic. Again, we're going to have a critical value on the left because it is a left tail test. And because we're doing a t-test, I'm looking here on my formula sheet. So I'm going to go to, let's see, inverse t. My area is 0.05. My degrees of freedom is n minus 1, so that's going to be 16. So negative 1.75. So that is my t critical. So now what I need to do is find my test statistics. So my formula for this, x bar minus mu divided by standard deviation over the square root of n. Negative 4.79. So this one is very, very extreme. Now, hopefully one of the things that you are gathering at this point is when we compare our critical value test statistic to our p-value, the more extreme the test statistic is, the smaller the p-value is going to be. So this one was more than one standard deviation below. This one, we're a long way below. So what I'm expecting now is I'm expecting a p-value that is just absolutely tiny. So according to my formula sheet, to do my p-value, I have to do TCDF, negative infinity to negative 4.79. Degrees of freedom was 16. So I get 1.001 times 10 to the negative fourth. So that means I have a p-value of 0.0001 because I had to move that decimal 1, 2, 3, 4 places to the left and fill in with zeros. So that is a tiny, tiny p-value, definitely less than 0.05. So we are able to reject the null. Now, the last thing that I have to do is run my confidence interval. And this is a t interval to go with a t-test. Now, what's nice here is we have it based on data that's already in our calculator. And what you'll notice is the calculator has actually already filled that data in. So you can leave it on stats and use that, or you can switch it to data and use L1. That's completely up to you. And maybe the older versions don't fill it in. But my confidence interval, I get 41.7 to 43.7. So my interpretation of this, I'm 95% confident that the actual mean height of kindergartners is between 41.7 and 43.7, which supports this decision because 45 is not in the interval.